Seguimos con el discurso principal del evento, que va a ser dado por la profesora doctora Regina Birner, de Alemania. Voy a presentar a la doctora Birner primero. La profesora doctora Regina Birner ocupa desde 2010 la cátedra de Cambio Social e Institucional en el Desarrollo Agrícola de la Universidad de Hohenheim, de Alemania. Cuenta con más de 20 años de experiencia de investigación agrícola orientada al desarrollo y ha dirigido numerosos proyectos de investigación en Asia y en África. Ha actuado como asesora de organizaciones internacionales, tales como la Mundial, la FAO y USAID, y ha participado en diversas evaluaciones. La doctora Birner es doctora en Socioeconomía del Desarrollo Agrícola por la Universidad de Tübingen. Hoy nos presenta el tema, la contribución de la bioeconomía a la sostenibilidad de la producción agrícola. Ya, profesor. Un fuerte aplauso, por favor.
Unfortunately, my Spanish is a bit rusty, and therefore I will talk in English with your permission, and thank you in advance to the interpreters. Please just give me a sign in case I talk too fast. Bioeconomy Council. I've been a member of this council since 2012, and therefore this topic of this event is very close to my heart. The contribution of the bioeconomy to the sustainability of agricultural production. So what I would like to address here are the following key questions. So first, what is bioeconomy and how did this concept actually evolve? Why do we need bioeconomy to make agriculture more sustainable? Maybe you already know the answers to these two questions, therefore I would like to concentrate more on the third question, which is what does the bioeconomy offer? Developing innovative bioresources strategies, using the power of biotechnological innovation, and promoting participation and dialogue. So, bioeconomy, there are many different definitions. I would like to present the one by the International Advisory Council on Global Bioeconomy, of which I'm happy to be a member. And the definition is that the bioeconomy is the production, utilization, conservation, and regeneration of biological resources, including related knowledge, science, technology, and innovation, with the aim to provide sustainable solutions, which could be in the form of information, products, processes, and services within and across all economic sectors to enable a transformation to a sustainable economy. And this was actually presented at the Global Bioeconomy Summit in 2018, where representatives of bioeconomy of many different countries got together and said, okay, we all have different definitions, but this one summarizes what we actually think bioeconomy is. How did the concept evolve? So in academia, the term bioeconomics or bioeconomy had actually been used since the late 1960s, mainly to describe that biological resources are actually the foundation of almost all economic activities. However, as a political concept, bioeconomy also has several roots. One important one is the European Union. In the 1990s, there was the experience that it was quite difficult to get any research support for agriculture any longer. It was not considered to be a very important sector, and therefore the Directorate General Research of the European Union started to look for broader concepts and started around 2000 to promote the term bioeconomy. And it was the EU Commissioner Potocnik at the time who in 2005 presented the first program on bioeconomy. Then a so-called Cologne paper was published in 2007, which outlined the vision of the European Union for the bioeconomy. And then, Germany had the first national bioeconomy research strategy in 2010, and since then we have actually observed an increasing number of bioeconomy strategies in many different countries. The International Advisory Council on Global Bioeconomy was formed, and 3 global bioeconomy summits have already been held since then. What is maybe also remarkable about this concept that it has been labeled initially as the knowledge-based bioeconomy because it was embedded in the vision of high technology industries based on science, innovation, and also high-skilled labor. And as outlined in the so-called Cologne paper, which was like a landmark paper at the time, 2 pillars of the bioeconomy were identified. And one we can describe as the resource substitution pillar or the bioresources pillar. So the idea here was to use biomass to substitute fossil-based energy and materials. So bioenergy, bio-based materials. And initially this was influenced around the 2000s by concerns that we may not have enough fossil resources, also referred to as peak oil. Later we identified that this is not really the major constraint. The major constraint is that we cannot actually use all fossil resources that are available because of climate change. And since the war on Ukraine, also concerns about energy security have further promoted this bioresources pillar of the bioeconomy. The second pillar, which also right from the beginning was essential for the bioeconomy, we can refer to as the biotechnology innovation pillar. So in the European Union, in these initial papers, biotechnology was recognized as important pillar contribution of the economy, driven by what is perceived to be a biological revolution. So the application of biological innovations in all parts of the society, not only agriculture, but especially also the industry, including the pharmaceutical industry, for example. And then bioeconomy also evolved in the last 15-20 years as a global concept. We have observed an increasing number of bioeconomy strategies since the 2010s, and here are quite a number of different examples. USA had a national bioeconomy blueprint since 2012. The province of Buenos Aires in 2016 published the Plan Provincial de Bioeconomía, and the national position paper was published in 2017. Brazil, of course, similar developments. And an analysis has been done of all these different strategies around the world. And what became clear that these 2 pillars, the bioresources, resource substitution on the one hand, and biotechnology innovation on the other hand, are actually prevalent in most bioeconomy strategies around the world. This was the picture in 2019. We see that many countries have either bioeconomy-related strategies, light green, or dedicated bioeconomy strategies that have this term in their title. An update is currently made, is in progress, and the next such map that will be published will be much greener and much darker green than it even was in 2019. But what we also observed, especially in the past few years, is what we can call the greening of the bioeconomy, because we have observed also a criticism against this concept, mostly by non-governmental and civil society organizations. And we can observe two types of criticism. One we can call the greenwashing criticism. Bioeconomy is not per se automatically sustainable. We actually have to make sure that it is. And there's also a more fundamental critique of green capitalism, which is more a fundamental critique of the entire economic system. And concerns regarding global food security have been also at the center of this criticism in view of the potential competition of biomass production for bioenergy and biomaterials on the one hand and food on the other. So what was the effect of that? That sustainability has been added as a third and somewhat overarching pillar to the bioeconomy concept. So bioeconomy is clearly linked to the Sustainable Development Goals and is increasingly seen as one of the different transformation pathways of the economic system to reach the SDGs. So some SDGs are very obvious, here in blue ones, socio-economic targets, so bioeconomy activities will contribute to reduction of poverty, well-being. There are the green arrows, bioeconomy will contribute to ecological goals. The red arrows, it will contribute to clean industry and economic targets. But depending on how we implement it, we can actually say that the bioeconomy will actually contribute to all the different targets. So in summary, bioeconomy as a transformation pathway has these two pillars: the bioresources pillar, use of biomass and biomaterials to replace fossil resources, and the biotechnology pillar, applied biotechnological innovations. And then we have the sustainability pillar, and the sustainability pillar can be achieved through various strategies, and I will mention some of them. So one is constantly assessing and monitoring the environmental footprint of bio-based processes and products, to promote the circular economy as an essential part of the bioeconomy, assessing social concerns, including to limit food competition, and also, very important, involving society, promoting participation and dialogue in the bioeconomy. And these are overarching pillars. Yeah, they have to be applied both to bioresources and biotechnology, so that in the end we can say we have the sustainable bioeconomy. So that is the picture or the framework I'm going to talk about when we come to the next topic. Why do we need bioeconomy to make agriculture more sustainable? And you could say that agriculture is at the heart of the bioeconomy, and the bioeconomy is at the heart of a green economy, which is a still more overarching concept that the United Nations have actually developed. So what role can agriculture play here? So first, I would like to start with a quick look back. What has happened with agriculture in the past 50 years? What you see in this diagram are different trajectories that show us how has the productivity of agricultural land, this is what we see on the vertical axis here, and how has the productivity with regard to labor, and this is what we see on the horizontal axis, how has this changed over time? And this is displayed here for different regions. So the beginning of each arrow, let's take the Latin American one, is where did agriculture stand in terms of land and labor productivity 50 years ago? And the end of the arrow is where are we today? And it is important for agriculture first to move up along the vertical axis, because that means we have higher yields. We can produce the same amount of output with less agricultural land. And we know that this is important for greenhouse gas emissions, for biodiversity. So we have to move up in terms of land productivity. But we also have to move on this horizontal axis, because it shows what is the return to agricultural labor. So this is essential for the well-being, especially of the farming community, that we actually also have a high return to labor. So moving up in both directions says that agriculture has been fairly successful, and we see it has been quite successful all around the world. The only one biggest problem is that labor productivity in sub-Saharan agriculture remains relatively low, associated with poverty in the sector. But in all other regions, we actually have seen quite some progress. And I think it is important to start with acknowledging this big contribution that has been possible because of innovations in the agricultural sector. And if you just look at specific countries here, I just plotted growth of agricultural output for Argentina and Germany, and we see both countries actually had a considerable growth, slowing down in Germany, still continuing in Argentina, and if we would add Brazil, we would see a similar picture to that of Argentina. And maybe some of you have seen this diagram before, but I think it is also very important because it shows us the sources of growth in global agricultural output. A diagram produced by Keith Hooley and colleagues from the Economic Research Service of the US. And they are using data from the Food and Agriculture Organization, also a long time series, to find out what has actually contributed to growth in agricultural output. And what we see on the horizontal axis is their percentage annual growth in world agricultural output. So the good news is that world agriculture has actually been able to keep pace with population growth, because the growth, annual growth in world agricultural output has been between 1.9 to 2.8% during all these decades. What we see in the stacked bars are what are the reasons why agricultural output grew. And we have the red one here. This is the expansion of agricultural land. Actually, a source of growth we rather want to avoid, because it is typically at the expense of biodiversity-rich land. We have the extension of irrigation, which may be a good thing if it's done sustainably. And then we have these light gray bars. This is more inputs per acre. And we see that the main growth of agricultural output in the early decades here, 1960s, 70s, also the period referred to as the Green Revolution, was mostly by using more inputs such as inorganic fertilizer, pesticides, seeds, and the like. And these inputs are often associated with unfavorable environmental outcomes. Therefore, what we want to see is actually the green bars. That is what the agricultural economists call improvements in total factor productivity. And that means through innovation, without using more fertilizer, for example, we can achieve a higher crop yield, for example, through genetic improvement, by improving the physiology of the plants, for example. So we see that we have actually made progress, but this progress always depends on countries' willingness, both of government and the private sector, to invest in innovation, in research and development. Because these green bars, they do not fall from heaven, they actually have to be achieved through investment and hard work, and also the willingness of the farmers, of the farming community to innovate. Now, we have looked at the positive side. We also have to look at the problematic side. It is widely acknowledged that agriculture is also a major reason that we move beyond what scientists Rockström and colleagues have called the planetary boundaries. You probably are familiar with this diagram. It is very famous. It shows the planetary boundaries. It shows various areas of environment, climate change, ocean acidification, land use change, biodiversity loss, and others. And scientists have determined how close are we actually to points of no return, points that as a global community we should not overstep because we may have negative, irreversible effects. And according to a study by Campbell and others in 2017, agriculture is unfortunately responsible for some major of these boundaries being close to reach. Agriculture is responsible for 80% of global deforestation. It uses 70% of global freshwater resources. It is, of course, the major user of nitrogen and phosphorus, contributes globally around 1/4 of greenhouse gas emissions. We could go into detail, for example, on biodiversity, but I will do this later. So obviously, the big challenge is agriculture has to change to remain within these planetary boundaries. And if we look at the global food security situation, the last report that was published, and the next one will be published soon, but this is the last one still available, also found from last year, a quote from the report, the world is moving in the wrong direction when it comes to food security and nutrition in the world. And why? Why? Okay, here. Here, sorry. So why? Because you may have also seen that picture, the number of undernourished people in the world, even though it has been declining in the long run, has actually been increasing. And it has been increasing especially recently, through COVID, the war in Ukraine, other developments. But the bad aspect is even since 2015, that was before all these events, actually the number of hungry people in the world has continued to, not to decline any longer, but to increase. And right now, the problem is not yet that we do not produce enough food in the world. In fact, we still do. So it is a problem of civil wars. It's increasingly also a problem of climate change affecting certain regions of the world. And if we look into the future, This is also the latest published projection of the United Nations 2022. We do expect to have 9.7 billion people in 2050. So the question actually is for agriculture, how do we increase food production sustainably? How do we feed the world in 2050 while remaining within the planetary boundaries? And at the same time also, with a view to the bioeconomy, sustainably use biomass for other purposes, such as energy and biomaterials. So that is actually the problem. So the question is, now what does the bioeconomy offer? And here I would like to come back to our model where we said we have these 3 pillars. So I'd like to first talk about innovative bioresources, strategies, then talk about the power of biotechnological innovation, and finally this issue of participation and dialogue. Not so sure whether this will work, but okay, innovation. Smart technological solutions. All right. Okay, so let's start with the bioresources pillar here. And so this is a diagram of bioenergy. Bioenergy is of course very important, but one of the big strategies of the bioeconomy, the bioresources pillars. What we see here is in blue the production and in green the consumption of liquid biofuels around the world. And the countries that are leading in the particular regions are also mentioned here. So we see that Central and South America comes second after North America, and then Europe comes third, comes fourth after Asia. So there has been quite a potential increase in using bioenergy across the world. And with regard to sustainable bioeconomy, we have to ask always the question, and here we come to this assessment and monitoring, how sustainable have we actually been in achieving this goal of replacing fossil by bio-based resources? And this is from a recent publication by Brazilian authors, Canavaro et al., published this year. It looks at biofuels production in leading Latin American countries. So we have ethanol in green and biodiesel in blue. And so we see Argentina here comes second after Brazil, as we actually all know. And here we have different feedstocks. So we have sugarcane and corn for ethanol in Argentina and Brazil, and then we also have soybean oil for biodiesel in both countries. Also included in the analysis here was palm oil in Colombia. Okay, and what did the colleagues do here? To assess the sustainability and also entry points for maybe more sustainability, they calculated the global warming potential of biodiesel as compared to fossil-based diesel. So on the vertical axis, we see gram CO2 equivalent per megajoule, that means per unit of energy. And here the dotted line is, so we are around 85 of this CO2 gram equivalent per megajoule. And then what they calculated is for different kind of feedstocks, and here's Argentina, here's Brazil, and here's actually Colombia. And here they looked at biodiesel from soy oil. And the blue part of this bar is how much greenhouse gas emissions come from farming, that means from the production of the soybean in this case. So we see the Argentinians' production is more resource efficient, more climate friendly, it looks like currently, as the one in Brazil. According to the article, that has a lot to do with the use of fertilizer. But then we also look at these at the light green bars, and this is the emissions that come from the production process of the biodiesel. And here we see a different picture. Here, in this case, the Brazilians are apparently more effective. So altogether, we still have a pretty good record, yeah, because all three types of biofuels are significantly more efficient. I have a significantly lower global warming potential as the fossil resources. But still, we see where the potential entry points might actually be. So, for example, you may all be familiar with the concept of regenerative agriculture. Yeah, so climate-friendly agriculture that could reduce emissions from farming, so that these approaches in the bioeconomy would become even more efficient. Now let's move to ethanol. Same approach here, it is compared to gasoline. And the fossil resource again has around 85 grams CO2 equivalent per megajoule. And here we see the first two bars are sugarcane and corn-based ethanol in Argentina, followed by sugarcane-based ethanol in Brazil and Colombia, and also in Guatemala. And what we actually see across the board here is that in general, corn is not so efficient because we have fairly high greenhouse gas emissions in the production process, because right now still relatively high amounts of natural gas are used for that according to this article. Yeah, so again here we have different opportunities. We see that Brazil is actually more efficient in the sugarcane production because of the use of what we can call circular approaches to increase efficiency in processing. So yeah, this is just an example, just an example of how we actually have to constantly assess and monitor and identify entry points for making bioeconomy more sustainable. And one approach to do this is the concept of the circular economy, and I would like to say a few words about that. This is a paper that we published with colleagues, and it has the title From Commodity-Based Value Chains, which is like the traditional approach, to what we call biomass-based value webs. That is the circular bioeconomy approach. And we used sugarcane in Brazil's bioeconomy just as an example to exemplify this concept. So what you see here is like the typical value chain approach. So you have the sugarcane crop processing, you get the juice and the sugar, so that would be the commodity-based value chain. But then once you consider how exactly the byproducts can all be used, the filter cake, the vinasse, the bagasse can be used for ethanol also, then we get the concept of a value web. And this can actually be further developed if we look at other aspects of all of this. So for example, use of bioelectricity, the production of biogas, all this then leads to certain residues, and the residues then can actually be used, to enhance the soil. So ultimately, we actually get a much more efficient system. And the study found that in Brazil has been a leader actually in many of these aspects. That's probably why we have seen the effect in the previous slide. But bioeconomy can actually get one step further, because, and this is only shown in dotted lines, out of various both products but also byproducts, such as, for example, the filter cake, there's a whole potential of new bioeconomy products that would add additional value: bioplastic, colorants, amino acids, lubricants, pharmaceuticals, enzymes, flavors, cosmetics, detergents. So the list actually goes on. And how can that be achieved? So the concept is actually the biorefinery. So there was a big discussion also last week in the International Council on Bioeconomy the biorefineries as a very important concept of a circular bioeconomy, and there's still a lot of innovation potential that is actually still underutilized. Okay, now another aspect of making bioeconomy more sustainable and offering solutions to agriculture is with regard to biodiversity. What I'm showing here is a diagram from a recent review of global literature on what has been the impact of bioenergy on biodiversity. So what we actually see here is for different kinds of crops that are typically used for bioenergy, what is, like a summary of the global literature impact studies, what is the impact on biodiversity measured here in biomass of insects and other biodiversity relevant species, and is compared to a reference system. So a reference system would be either the natural vegetation that was there before or low intensity use such as pasture. And the dark dots are the abundance, so how many biodiversity relevant species are there? And the other one is the diversity. So diversity is how many species, and abundance, what is actually the total number or the total biomass. And we see, unfortunately, for all these crops, they lead, to some extent you can say expectedly, to a decline in biodiversity. And what is called row crops, that is actually a rotation of corn and soybean, or the soybean, they actually look particularly negative here, versus tree crops like poplars look somewhat better. So the question is, what are bioeconomy solutions to deal with this problem? And the idea here is making farming systems biodiversity smart. And what does that actually mean? In a recent paper we published on the topic, we make the following point. The conventional strategies that we observe to increase biodiversity, especially in crop production systems, are integrating flower strips and hedges in the agricultural landscape, reducing pesticide use, and many others. In the European Union, farmers get actually payments for that. But the problem with these strategies is that they reduce the agricultural production either by reducing yields, if you reduce pesticides, or by reducing land available for production, if you set aside lands for the flower strips. And in view of the challenges, we see that it may not be particularly smart. So what is smarter actually is farming strategies that enhance biodiversity in farming systems without compromising, at least compromising too much, of land and labor productivity. Remember the diagram we have seen, we need to not slow down in these trajectories. And there are many interesting examples. So I just mentioned some of them. New designs of farming systems, like farming in stripes, integrating new species in farming systems, or establishing agroforestry systems. And you may be familiar with all these debates. I think they're equally relevant right now in the European Union as they are in Latin America. So just one example is this strip intercropping. This is a picture from Germany where conventional wheat and oilseed rape is intercropped. So that can be done with the regular machinery, no new investment needed. And the agroecologists could show that just this intercropping significantly reduced the pest pressure in both systems. So this is an example of a new design that does actually not take away any land from production and still can have a beneficial effect. Others are actually very well known in Latin America, that you can grow beans and maize together. It's actually a very traditional established system, but this is now also introduced, for example, in Germany, because it also enhances biodiversity without compromising too much, for example, if that maize is used as an animal feed. Or other examples are, this is not necessarily only beans, but there's also the possibility to include other flowering plants, and a lot of research is actually going on to find out where do we have the most beneficial effects of both. Yeah, because we don't always have only beneficial effects. We can also have negative effects if that plant happens to be a host plant of pathogens. Yeah, so again, it is a very research-intensive activity to find out how can we make agriculture more biodiversity friendly. Yeah, and a third example is multiple-use bioenergy crops. This is also an example from Germany. Very innovative farmers, and they grow common cup plant, Silvium parfoliatum, as an alternative energy plant. So it is actually biodiversity friendly. It is very resistant to drought. The fibers can be actually used for making paper, and then the residues are used for biomass. Yeah, and potentially, of course, there are many plants that could be used as energy crops, and the idea here is to look at multiple objectives at the same time. Yeah, so actually higher returns in terms of energy, positive effects in terms of biodiversity. Okay, now let's, in view of the time, let's move to the second pillar, the biotechnology pillar. Yeah, so apply biotechnological innovations for new products and more efficient processes. So what does bioeconomy have to offer here for agriculture? And of course, if you look again at the past developments, here I have soybean yields between 1960 and 2021 in Argentina as compared to South America. And you've seen, of course, with annual fluctuations, an enormous increase in yield, from 1 ton to almost 3 tons in a period since 1962 to 2021. Yeah, and that is part, of course, of what I showed earlier, part of this trajectory that you actually move land productivity up. Yeah, and there is no doubt by anyone that the use of biotechnology in crop breeding, various technologies that have been used, whether it is marker-assisted breeding, whether it's actually genetic modification, that this has contributed, of course, next also to other crop practices, but it has been a major contribution to increasing yields. Yeah, so biotechnology has been used for a very long time in agriculture with good success, one can say. But on the other hand, what we also observe is if we look at pesticide use, we might have expected that innovations in biotechnology, but also innovations in precision agriculture would have led to a reduction in pesticide use. But if we use the average application in kilogram per hectare, we don't see a decrease. Of course, this might not be the best indicator. Ideally, we want to look at active ingredient, and ideally, we also would like to look at the toxicity of the pesticides. Certainly, the toxicity of the pesticides has been reduced considerably. Many pesticides that were in use in the 1980s, when I did an apprenticeship in agriculture, are actually not allowed anymore. So certainly there was progress, but if we look at the overall figures, we actually need more progress. As you know, the European Union, for example, has set a target, reduce pesticide use by 50%. Yeah, so if we look at what happened in the past 30 years, we really have to move into a different direction. And how is that actually possible? Of course, there are many different possibilities that we can use. So one is actually not about technological innovation, but these are innovations in the agricultural engineering side, in sensors, for example. What we see here is a picture of 2 graduates from Hohenheim University who just last week gave a talk to our students on the company that they founded, Sam Dimension. And they figured out a very efficient mechanism to use drones to, in very high speed and very high resolution, create application maps that then would farmers allow spot spraying. The technology in the spraying equipment is actually already there. So the ultimate goal is to identify, even the individual weed, and then you can reduce application by up to 90%, depending on what it is. And similar ideas are being used to detect not only weeds, which is perhaps more obvious, but also to detect other kind of disease problems, and then using precision farming to reduce application rates quite considerably. Or another approach is to move from chemical to mechanical kind of strategies. And here, this farm droid weeding robot is actually not just a nice company picture, that is actually in the field. So for example, sugar beet farmers in Germany are using it. Also Südzucker, one of the major companies, is using it on their research farm. And it actually works. The problem is that it is still more expensive than chemical pest control. So therefore, right now in organic sugar beet, it is actually a solution, but the cost would have to come further down if we actually also wanted for other solutions. So this is a totally automated system that uses solar energy to actually drive the robot. It's able to identify the individual sugar beet plant. Okay, now let's come to the biotechnological innovations. I already mentioned we have actually a huge potential on using biotechnology in crop breeding. But here we have more societal issue. As you all know, the world is pretty much divided when it comes to transgenic crops, which are widely grown in Latin America, North America, other parts of the world, but banned in almost all European countries. There's been a big debate on new genome editing methods. Scientists agree they do have a huge potential. Also to make agriculture more biodiversity friendly, for example, by further reducing pesticides, by having more resistant crops, and so on. But you may have followed this debate. It is still actually contested in the European Union. The regulatory framework is still evolving. But NGO protests and societal concerns remain rather high, so it remains unclear to what extent that potential will be used in the EU. But I have no doubt that it will definitely be used in Latin America and other countries that have been more open to these kind of innovations. Then, of course, there's a huge potential in using biological plant protection products. It's a major focus of this conference. Therefore, I don't want to talk more about it right here, because I'm sure the most interesting things about it you will learn later. Well, there are always open questions. So what is actually the best fit strategy? And in agriculture, many answers depend on the local context. And they also depend on regulatory frameworks, societal preferences. So should we rather go the precision farming route and reduce agrochemicals? Or should we try to replace them altogether? And again, the recommendation is to try to provide at least a rigorous analysis based on scientific evidence to make more informed decisions. So for example, if we look at multiple criteria, greenhouse gas emissions, at the same time biodiversity, it is unclear whether mechanical crop protection is necessarily better than a very precise chemical crop protection. But these are questions that scientific evidence is required to answer. Then let me come to participation and dialogue. If we want to use bioeconomy as a transformation strategy in agriculture, we have to acknowledge there are unique potentials. I think that has become clear, both with regard to bioresources and biotechnology, our two pillars of the bioeconomy. But it also requires major changes, and not only by the farmers, but by all actors in the innovation system. By the advisors, by the processors. If you look at the new biorefinery products, we actually need also new linkages, for example, with the chemical industry, that maybe traditionally have not been part of the innovation system. And therefore, and also acceptance by society, I already mentioned that. And therefore, it's important to engage stakeholders. Participation and dialogue are important. That's why I'm very happy to be here today, because I think this is one such event where different actors come together and discuss the future. And there are many different examples, roundtables, the concept of the innovation platform. I read in the literature that this is also being promoted in Argentina and Brazil, also in Germany. So bringing also new stakeholders in, discuss together from the beginning of an innovation process onwards. At our university, we have created what we call Hohenheimer Landwirtschaftsdialog, Hohenheim Agricultural Dialogue, because we said also the universities, they have to be places where these debates are actually, issues are debated, and the voice of science can actually enter these debates. So I think that's actually a task for everybody. And there's also the idea of citizen science. We have a lot of interesting examples. Citizens are often really excited. They use their apps to look where is biodiversity, maybe the natural landscape. They could maybe also see where is biodiversity in agricultural landscape, so they could actually all contribute. And what is also very important is promoting local and regional initiatives. So in the future we want to see, or we're already seeing, bioeconomy villages or bioeconomy regions. Because our observation, we do a lot of research on what happens on the ground, what happens in smallholder systems around the world. We often find the innovativeness, the ingenuity of local people is actually much bigger than we think. Quite often, as scientists, we sit at some high-level table and think about whether something is not possible at all, and then we find actually on the ground it's already being done. For example, in one of our projects, we looked at carbon-neutral value chains. The advisory council of the German ministry was still debating, can we really do this? Is this not too difficult? And then one of my PhD students found that it was actually a cooperative in Costa Rica, in the mountains there, which was the first one worldwide that was able to certify their value chains by the international standard of the British Standard Institute. So they just actually did it, while others were still debating. So I think it's very important to look at what is going on the ground. And one example here from Germany is called Bioeconomie Revier. Revier is the name of a region that was dominated by open cast lignite coal mining, and coal mining will be phased out in Germany. So people got together, they also have an English website, so you can actually look at it, got together and say, okay, we actually use bioeconomy. We will lose labor, we will lose workplaces in the coal industry. We will develop new ones in the bioeconomy. And they have been one of the most active, proactive, actually actors, stakeholders in the German bioeconomy, people from this particular region. Okay, I would like to come to an end to leave also some room for your questions. So, summary and conclusions. We can say bioeconomy emerged as a global concept in the past 2 decades. It has 2 major pillars, bioresources and biotechnology, and both offer unique opportunities for agriculture. We have seen that bioeconomy can make agriculture more sustainable, but it does not happen automatically. We have to make active efforts to apply circular economy principles to make sure that we always assess and monitor bioeconomy products and processes according to multiple criteria, such as competition for land, greenhouse gas emissions, and biodiversity. And that may lead to the design of new farming practices, such as the one I have shown. And last but not least, bioeconomy requires dialogue and participation, and regional and local approaches have a great potential in this regard. Thank you very much for your attention.
Muchísimas gracias por esta presentación. Pienso que todos estamos como un poco overwhelmed. A lot of information, mucha información, pero muy gráficamente y lógicamente organizado, o sea, excelentísimo. No hemos previsto hacer preguntas, pero tenemos dos preguntas de los participantes online. We have two questions from our online participants. I'm trying to translate them from Spanish into English. And we have later, don't worry, we have later a lot of time for questions also during the panels, so you will get your question out into the world. The first question is, what's the German government's position on these new innovations in bioeconomy, especially talking about biotechnology in the food production? First question.
Okay. So the German government is, as you may know, ruled by a coalition of parties, including the Green Party, the Social Democrats, and the Liberal parties. And the different parties have somewhat different views on these issues. So there's a big agreement on like these new farming practices like strip intercropping and so on. Everybody's in favor, yeah, because you don't have concerns on this in this regard. The question is such is only, you know, how can the instruments of supporting farmers be adjusted so that farmers can actually also be paid out of, let's say, the second pillar of the agricultural policy. It gets more tricky when it comes to biotechnology. And biotechnology in the food processing industry is not much contested, not, you could say yet, but it has not been a focus. I mean, we have a lot of biotechnology in food processing, but it's contained systems, and they have not been the target of major NGO campaigns, so there's actually no concern about that. The big concern is about using of biotechnology, especially gene editing, in field crops. And there we have seen a slight movement in the Green Party to be more open to these approaches, but it still remains rather contested. And I think because of the very heavy NGO focus on that, I think internally the NGOs agree that on a scientific basis it is hard to argue against it, but it has been, one of their major campaign issues for decades, and my personal opinion is that this is not so likely to change, but it remains to be seen.
Okay, thank you very much. Second question, considering the conventional agriculture for the last 100 years has produced food for everybody and now is able to provide food for 8 billion people. What is your thinking on how will it take, or could it take, to transform from conventional agriculture to more bioeconomy-based agriculture in order to get the same results, the same yields overall? And then there's a second question to that, what might be an extra cost or even savings to do so?
Yeah, so this transformation, I think one of the biggest problems is that we do not have a consensus on where to go. Yeah, I observe both nationally but also internationally, and I think also in Latin America, there are like two paradigms. Yeah, and one is the paradigm that the only sustainable way would be organic or agroecological. And that position is often associated with the ruling out certain practices. not necessarily on a scientific basis, but on the basis that this is part of the concept. And that includes the use of pesticides, which I think is still debatable, but also excludes the use of inorganic fertilizer, where I think the scientific basis of making such a demand is maybe even less justified. But this is one approach, and it's associated with certain worldviews on what the role of multinational companies in agriculture should be, and so on. Now, on the other hand, you have this paradigm that is actually associated with innovation, modernization, quite often also a bit blind to the actual environment problems. And I think what should be promoted is, on the one hand, acknowledging organic agriculture can be a certain business strategy when you can market this product. I think it's a perfectly justified business strategy, and if you find a certification for agroecological, it will also be. But I believe it will because of the yield effects. According to global reviews, globally you have 25% less yield in organic agriculture. There's huge variations, but several meta-studies say that. So it will always remain more expensive, so I think it will be a product for a certain market. So even if it's 20%, which would be 4 times than what it is today, there are still 80% conventional agriculture. So the big question remains how to make conventional agriculture more sustainable. And I think there are numerous opportunities, and I think societies would be well advised not to take out of their own hands the innovation opportunities they actually have, such as precision agriculture, the use of digital agriculture, the use of biotechnology. How fast can this actually go? My impression is, looking at the past, farmers have an enormous innovative potential. Otherwise, they would not have been able to triple production in such a comparatively short time. So I do not think that the innovative capacity of the farmers is actually the problem. I think it is rather finding a consensus in society where we actually want to go and create the frame conditions for the farmers to actually go there, and not to cut back on the investment in research and innovation that's actually required. And a sense of urgency, as we have seen in the Ukraine war, can actually help. But in principle, I'm quite optimistic that the capacity and the potential solution that bioeconomy offers would allow for rapid changes.
Okay, thank you very much, Dr. Birner. Big applause, please. So, creo que ha sido un buen cambio de las conclusiones de la señora doctora Birner hacia el panel, porque es justamente la temática que queremos ver aquí, ¿no? Con ustedes, es cómo encontramos un camino en común hacia adelante, porque también nuestra experiencia ahorita es más bien así que cada uno va por su lado, intenta hacer cosas, pero no hay mucha concertación en conjunto. Hay mucho potencial en esta dirección.